it will include all the other positive integers. Okay, this is just to confirm that you understand, because in a fraction you will actually see some of these natural numbers or integers coming into picture. So let me just come to fractions quickly with a good example. So how many of you like to eat pizzas? Yeah, most of us like to eat pizzas. I think it's fine to eat maybe sometimes. So let's take the example of a pizza. So imagine that, where is this? Okay. Imagine that you invited some friends over to your place, and you had a good time and you ordered a pizza at the end. Maybe it could be, maybe you guys played some table tennis or badminton and whatever. So you ordered a pizza and there are, let's say, three of you. So what would you do? So I'll just draw hopefully a good picture. Let's see. This is a pizza and this is pepperoni. Anyway, so you have, let's say, how many slices do you see currently? So you have one, two, three, four, five, six. And remember, there are three of you. You have invited the three friends, so there are four of you actually. So suppose all of you eat one slice. So that means four slices just consumed, right? And in total, how many slices will make one pizza? It will be six. Okay, so four are consumed. So let's say the consumed ones, let me mark it by something like this. This is gone. Okay, eaten. Or I can draw a face picture also. This is eaten. It's in the stomach, right? So what has happened is just two are remaining, and each of your three friends and you has basically all of you have eaten one each. So six would constitute one whole, and four you have eaten, right? Now, if you denote this in this type, which is 4/6, right? This is an example of a fraction. Okay, this is an example of a fraction. So this fraction represents the number of slice eaten and what would constitute about one entire pizza. But this is to just make you understand. I think 1 second. Yeah. So this we talk about this as fraction. Now, look, you can always simplify fraction. If it is 4/6, use your common sense. Tell me which number will both be divisible by. Maybe two, maybe three. Just use your common sense, okay? So you can further simplify it. It will still remain a fraction, even if you simplify it. Okay. Now, tell me the nature of 4 and 6. We just did some terms at the beginning, right? So what do you think is the nature of 4 and 6? Maybe I'll give you options. So it is natural numbers, negative integers, positive integers. Think about those options. Okay. I'm not writing the options, but because I think I expect you to know this. So all of you see that this is nothing but an integer. And so the options were integer, natural numbers, and negative integers. So this is an integer. Let's call it P. This is an integer. Let's call it Q. Okay. So what I've done instead is I've given a general term to this part and this part, which is numerator and no. So I've given a general term. Now, if you have not 4 and 6, but any other integer, which is generalized as P. P here means what? It's an integer. Q here means what? It's an integer, right? So my question is, do you think it will remain a fraction? Okay. Yes, no, maybe. These are the options. So the options are yes, no, maybe. If I replace this 4 by p, which is an integer, and replace this 6 by q, which is also an integer, do you think that this fraction will remain a fraction? What do you think? So the answer is yes, except one case. The case is, so you can have a p by q form. It will be a fraction and it will also be a rational number. Okay. Why it is a rational number, I'll come to it. So this is of the form p by q. It is a fraction, yes, except one case that q is not equal to 0. Then it is not defined. Okay. So the answer is p by q form. It will remain a fraction where p and q are what? Integers. And this is what is the definition of the topic today. That is a rational number. Okay. So if you are asked to identify whether something is a rational number or not, This is what criteria. You have to see whether it's in the format of P by Q, whether Q is not equal to 0, and then you can go ahead and think of it as rational number. Okay, let's see another example. Let me quickly erase this. So the another example that I have in mind is uh, just a minute. Just give me 1 minute, I'll be back. Hey, sorry. So we'll continue with where we left. I think we left at the idea about rational numbers, right? So any rational number, it is has to be of the form P by Q. Okay, we'll see some little. I think no, we'll make it simpler. So now I'll discuss how you can actually convert any rational number into a decimal. So we'll take another example now. What example should I take? Okay, what's your weight? When you think of your weight, you might have something in mind, right? It's 75 kgs, it's 56 kgs, it's 80 kgs. I think most of us might not remember the decimal part. So actual weight might be 80.4 or it could be 60.8. We don't say my weight is 60.8 kg because I mean in common language, we would rather it's convenient and it's simple to say that okay, it's 60 kg, it's 64 kg, and so on. So that's the idea. Thus, when we talk about 60.8 kgs, it's nothing but 60, which is the whole part, just like I'll come to another example, and then the zero point 0.8 part, right? Now, this part is what? Is less than 1, because if it was more than 1, I would have added 1 to this part. Now, this part does not have any decimal. It's a positive integer. It's a natural number. But this part has a decimal. So how do we convert any rational number into decimals? That's the core idea. I think there are multiple ways, but I'll keep it very short here. Maybe I'll give you one question to understand. Maybe you can do it yourself, maybe. So I'll give you one question over here. So the question is that you took a test. Maybe it was a maths test, which you are good at, I'm hoping, and you happen to answer, let's say, five out of what 8 questions right. I mean, this is not a the questions were of good level, let's say. So you got 5 out of 8 questions right. Can you tell me what is the percentage? So take a moment and think of a percentage. You can also take any other example, not just any other number instead of 5 and 8. That's up to you. So maybe you can take 2 out of 4 if it is simple for you. Okay. So let's see what happens. So the moment to take let's say the simple one, which is 2 out of 4, if I convert into percentage, if I convert into percentage, this you will have to multiply by 100% and then you'll get a 50%. I think this basic idea most of us have. Why do we multiply? What is the symbol? I'll not go into that. But the idea over here is, see, this 2 by 4, was it a rational number? Yes or no? The definition, go back to the definition. So it was a rational number. Now, when you convert a rational number into percentage, it becomes 50%. So what happens is 50% means what? It is 50 upon 100, because percentage symbol itself is by 100. Now, now remember, if it is 50 upon 100, which is that on a scale of 50, it's on a scale of 100, it's 50. Okay, which means it is not crossing 100. If it is not crossing 100, the value of this should be less than 1. Or what is happening is out of 4 slices of pizza, which constitutes one complete pizza, only 2 have been eaten and 2 are left, which means this 2 out of 4 will be less than one pizza, of course. That's the idea. Now, what would we do if you want to convert this into decimal? See, look at this example. If there are two zeros, so cancel one zero, you are left with 1 0. Think of that zero. What happens when you see a thing from far? It appears like a point. So you remove this zero, put a point over here. Always start from the digit which is on the rightmost side. In this case, you only have one digit, so I started from 5 itself, and then put a point here. And on the left hand side of point, it's always going to be zero. So it's going to be written as 0.5. And if it ends here, it means there's nothing. It's zero again. So you can think of it 5000. It basically it ends at 5. That's the idea. Okay. Now this was a simple example where you could have used this percentage trick. And when you have this 100 in the denominator, you can easily make and convert into decimal. But there are this one, maybe I'll do one more example here so that you understand this hopefully better. So what happens over here is, suppose I take a number like 5 upon 15. Okay. First, always simplify. It becomes 1 upon 3. Now, if you see a number which is less than the denominator, then add zeros. I mean, that's how you multiply also. If it is, so if you add 0, what happens is that then you will divide. So you'll get 3, but then you'll be left with 1 by 3 because this is nothing but 3 plus 1 by 3. Understand, 3 parts make one complete part, 3 parts. And if you want to go to 10, you will have 3 plus 3 plus 3. That is 3 complete units, right? And then you are left with 1 unit. Now this 1 by 3 will have to be further converted into decimal. How do you do that? Add a 0 here, add a 0 here. This becomes 33. But this 0 was not, this was artificial. I call it artificial zeros. Then you put a point over here. Why over here? Because two zeros. So 1, start from the right, 1, 2. So it becomes 3 plus 0.33. But the catch here is that unlike, it never ends. It just goes on. 3, 3, 3, 3. It just goes on, right? Which means that a rational number might have a decimal which just never ends. It never terminates. That is possible. Is that possible? Yes. But it's repeating in nature. It's like 3, 3, 3. It's always the same kind of numbers. 3, 3, 3. Sometimes it might also have, let's say, 2 and 4, 2 and 4, 2 and 4, and so on. But it's repeating in nature. It's not terminating, and it's also, but it's repeating in nature. And that's the idea about rational numbers, right? That is how you can convert rational numbers into decimals. And the importance of decimals is when someone asks your accurate weight, right? 84.5 kgs, it, right? So I'll end it here. uh, I hope you enjoyed. See you in the next session. Bye.